I was recently looking at some data from a high-level logistics hub, and I saw something that felt, I don't know, completely disconnected from every headline you've read this year. You have to imagine a massive, sterile warehouse floor, the kind where, every square inch is worth a fortune. And on one side, you have all the political rhetoric. You hear talk of ironclad sanctions, total decoupling, technological containment. It's loud, it's aggressive, and it really just sounds like a door slamming shut. But then you look at the shipping manifests, and quietly, almost rhythmically, you see these crates containing the world's most powerful AI hardware, the NVIDIA H200, being moved in just staggering numbers. We're talking about a reported 400,000 units, all of them destined for Chinese tech giants. And that number, it's so large, it starts being a commercial transaction, and it starts looking like the mobilization of a digital army. What's fascinating isn't just the sheer volume of it all, it's the attitude of the people behind the scenes. When I spoke to a contact who's involved in hardware procurement, he wasn't worried about the trade war or the tough on China speeches coming out of Washington. He had this calm, almost clinical detachment. Tim, the sanctions weren't a wall. They were just a set of variables in an engineering problem. He described a quota system where for every high-end foreign chip they bring in, they're forced to integrate a specific number of domestic ones. He called it polishing the stone. Using the world's best tech to sharpen their own local industry until the foreign stuff is no longer needed. But this is where it gets truly bizarre. While the West celebrates these restrictions as a victory for national security, the ground reality suggests the opposite might be happening. By trying to starve the beast, we've inadvertently forced it to evolve at a 30-year pace. The sanction party isn't panicking. They are stockpiling the 21st century's version of steel and oil with a terrifying level of discipline. And that sudden realization that the very tools meant to cripple an adversary are instead being used to build an unassailable supply chain fortress, it just left me stunned. It makes you wonder, is the West actually winning a tech war, or are we just watching a masterclass in how to turn a blockade into a launch pad? To understand why 400,000 GPUs are moving across the Pacific right now is to understand the cold, hard logic of computing sovereignty and why the maps we're using to navigate this conflict might be completely upside down.
It's a really striking image. And that disconnect you're talking about between the political theater, the slamming doors, and the operational reality of those loading docks, that is exactly where we need to start this deep dive.
Right. It feels like two different worlds.
They are. And to understand what's happening here, you have to completely abandon the standard framework of trade wars or market competition. This isn't about quarterly earnings for NVIDIA, and it's definitely not about consumer electronics.
It's something much bigger.
When you look at the logistics data, you realize that the maps are indeed upside down. The West is looking at a map of restriction, while the East is looking at a map of accumulation.
Okay, that accumulation, that's what I want to dig into first. When you hear 400,000 chips, it sounds like a lot, but in the context of global trade, numbers get thrown around constantly.
Right.
Is this just a big shopping spree, or does the scale here imply something structurally different about what's happening on the ground?
It's absolutely structurally different. We have to look at the physics of this power. We need to move beyond the headlines and look at the sheer weight of this mobilization.
The physical reality of it.
We're talking about 400,000 to, well, potentially up to 900,000 NVIDIA H200 units.
900,000.
That's the high-end estimate floating around. And to put a dollar figure on it, we're looking at a deal worth roughly 10 billion US dollars. But even the money obscures the reality.
So?
Because this is the acquisition of a strategic asset class. This is not inventory that you're going to sell. This is capacity, foundational capacity.
So we shouldn't think of these as gadgets or products. This isn't like buying 400,000 phones to sell to consumers.
The best way to think of it is as digital steel.
Digital steel?
If you look back at the 20th century, industrial capacity was defined by steel output. How many tons can you produce? That determined your ability to build tanks, bridges, skyscrapers.
The entire backbone of a modern nation.
In the 21st century, that metric has shifted. It is now defined by floating point operations, or FLOPs. That is the raw capacity to process information, to run simulations, to train intelligence.
So the H200 isn't just a faster chip.
No, it's a foundational building block for sovereign capacity. When a nation secures this much compute, they're securing the ability to model the future, whether that's in pharmaceuticals, fusion energy, or, military logistics.
And specifically, this isn't the watered-down stuff we used to hear about, right? I recall seeing reports about the H20, which is that compliant chip designed to meet U.S. export controls. But the manifests we're seeing now, They aren't listing the H20.
Correct. And that is a critical distinction. The H20 was the stripped-down version. It was hobbled to meet export controls. The H200 is a different beast entirely.
How different are we talking?
It is a serious accelerator comparable to late-generation H100s, and it's capable of training massive multimodal models. This is the hardware you need if you want to be a serious player in generative AI, in complex simulations, and things that have dual-use applications across the board.
So we're talking top tier, or very close to it.
Very close. The memory bandwidth alone, the HBM3E, allows for data throughput that fundamentally changes what is possible in training large language models. This is why I use the term digital steel. It is the raw material that allows you to build the structure of a modern digital economy.
I want to circle back to the logistics aspect you touched on. In the intro, I mentioned this idea of the midnight pulse operation. My contact described a feeling of heaviness surrounding these shipments. It wasn't just boxes moving on a conveyor belt.
That narrative is incredibly revealing. It tells you everything about the state mindset. You have logistics coordinators tracking these crates, and they describe a feeling of gravity. It's almost psychological.
A weight beyond the physical.
Yes. When you are moving 400,000 units of the world's most advanced compute, you aren't just moving silicon. You are moving the potential for economic dominance for the next 50 years.
And the security reflects that.
The security measures, the precision, it's described as building the Great Wall of the Cloud. It's not code, it's physical weight. These shipments are treated with the same level of security and precision as bullion or weapon systems. It grounds the ethereal concept of the cloud into something that arrives on a pallet and gets plugged into a wall.
That physical reality is so crucial. But let's look at the policy environment that allows this. I mean, why is this massive movement happening now? The narrative in Washington is the door is shut, but clearly 400,000 units suggest otherwise.
The door is shut, but there's a window, and that window has a toll booth. The U.S. policy shift has effectively created a mechanism where these chips can be sold, but with a 25% import tariff, which is effectively an export fee plus rigorous third-party testing requirements.
So the logic from the U.S. side is, if they're going to get them anyway, we might as well tax them and use that money to fund our own ecosystem.
Washington sees this as closing a loophole while generating a massive revenue stream. They view it as taxing the adversary. But, and this is the critical divergence in perspective, you have to shift your view to the Chinese procurement officer.
To the person standing on that sterile warehouse floor watching the crates come in.
To him, that 25% fee is negligible. It is a rounding error on a strategic investment.
A cost of doing business.
Less than that. If you view these chips as the seeds of sovereignty, as the essential raw material for your civilization's survival in the digital age, you do not care about a transaction cost, you pay it gladly. Washington sees a revenue stream. Beijing sees a window to finalize a supply chain fortress.
Wow. That disconnect is profound. One side thinks they're winning by collecting a tax. The other side thinks they're winning by securing the future.
And that brings us to the core of the strategy, because it's not just about hoarding these chips. It's about what they're doing with them. And this is where we get into the quota system and this concept of polishing the stone.
Right.
This is arguably the most sophisticated piece of industrial leverage we have seen in decades.
Polishing the stone, it sounds so patient, so deliberate. Explain how this one-end procurement strategy actually works on the ground.
It is a brilliant piece of industrial policy. The mandate is often referred to as a one-end strategy. It's a ratio. For every one high-end foreign chip like an NVIDIA H200 that a company brings in, they are required to integrate a specific number N of domestic chips.
Like the Huawei 910C or chips from Camericon.
Exactly. It creates a forced linkage between the import of superior technology and the adoption of developing domestic technology.
So you can't just buy the Ferrari. The government says, fine, you can have the Ferrari, but you also have to buy 3 of our locally made sedans. But more than just buying them, you have to integrate them into your fleet.
And the logic goes deeper than simple sales figures. You don't ban the foreign tech immediately. If you did that, your entire industry would crash because the domestic tech isn't ready yet. It's not competitive on its own.
You'd be cutting yourself off at the knees.
Right. So instead, you use the foreign techs, the H200, as the benchmark. It becomes the whetstone. You plug the foreign chip in right next to the domestic one in the same server rack. You use the NVIDIA chip to train your systems, to set the standard for performance and stability, and you force your engineers to make the domestic chip perform at that level.
That aligns perfectly with that story of the site engineer, the one they called Old Chen. He views the foreign chip not as a savior, but as a temporary tutor.
Yes. a very expensive but very effective tutor. The foreign chip is there to sharpen the local industry until the foreign stuff is no longer needed. Once the domestic ecosystem catches up, aided by this forced integration, by the real-world data, by the direct comparison, then you cut the cord yourself.
You don't wait for the sanctions to work.
You make the sanctions irrelevant. It is a controlled environment where the superior foreign technology is used to debug and accelerate the domestic alternative. It's a live-fire training exercise for your entire tech sector.
It effectively turns the reliance on foreign tech into the very mechanism for ending that reliance. It's kind of a beautiful strategic judo move.
It is classic asymmetric strategy, and it's being formalized. This isn't just an informal understanding. We have seen reports of the Xinjiang Directive or the Information Technology Innovation List.
And that comes from the top, right? The Ministry of Industry and Information Technology.
Correct. This is official state policy.
So what does that directive actually entail for the market structure? How does it change how companies operate?
It effectively tells state-run institutions, we're talking banks, hospitals, government agencies, the core of the public sector, that they must pivot to domestic suppliers. It creates a bifurcated market strategy.
Bifurcated, meaning two distinct tracks running at the same time.
Two tracks operating in perfect tandem. Track one is the public or state sector. They provide a guaranteed captive market for domestic chips, like Huawei's Ascend series.
So if you're a Chinese chip maker, you have a guaranteed customer base.
A huge one. And this gives those domestic companies the revenue and, just as importantly, the user data they need to iterate, fix bugs, and improve. They have a safe sandbox where they can't fail because the government mandates their use. This provides the baseload of demand that allows domestic manufacturers to scale production and work out the kinks.
Yes, that's track one, so what's track two?
Track two is the private sector. The big tech giants like Alibaba, ByteDance, Tencent. They're the ones allowed to import the H200s.
Why the special treatment for them?
Because they need to compete globally right now. If you forced Alibaba Cloud to use inferior domestic chips today, they'd lose market share to Amazon Web Services or Google Cloud tomorrow. So you let them have the digital steel, the H200s, but under strict observation. The implicit understanding is that they must eventually migrate as the domestic tech matures.
It's a generational relay. You let your fastest runners use the best foreign-made shoes for the first leg of the race, while your own factories are busy sewing even better shoes for the second and third legs.
It avoids the trap of total isolation, which absolutely kills innovation, but it also prevents total dependency, which kills sovereignty. It is walking a very, very tightrope. But the discipline we are seeing is remarkable. It demonstrates a high level of coordination between industrial planning and market reality that is, frankly, hard to find anywhere else.
So we have the chips, this massive stockpile of digital skill, and we have the strategy, this polishing the stone quota system to use them to build domestic capacity. But chips, as we said, represent only potential. They don't run on air. They need power.
A tremendous amount of power.
And this is where the numbers get absolutely mind-blowing. I was looking at the energy stats in our source material regarding the infrastructure build-out, and it's just staggering.
This is the electron gap. And this is arguably the most under-discussed aspect of the entire AI competition. We focus so much on the silicon, but we often ignore the electrons needed to make it think.
The numbers paint a very, very stark picture.
In 2024 alone, China added an estimated 429 gigawatts of power capacity to its grid.
429 gigawatts in 1 year.
To put that in perspective for you, in the same period, the United States added roughly 51 gigawatts.
That is an immense disparity. It's not even in the same league. It's more than 8 times the capacity addition.
It is an order of magnitude difference. And this brings us to what you could call techno-realism. It's a very grounded perspective. You can debate regulations, you can pass laws, you can have ethical summits about the future of AI. But if you have the chips and you do not have the power to turn them on, you lose. It is simple, brutal physics.
And where is all this power coming from? Is it simply a matter of, burning more coal, or is there a structural advantage in how this grid is being deployed?
It's a mix, of course, in all of the above strategy. But the geography and the grid architecture are key. They are building these massive data center clusters in the interior highlands, places like Guizhou province.
Right there.
A few reasons. They have vast stretches of flat land. They have a cooler climate, which helps with data center cooling costs. And they have massive renewable energy integration solar and wind on a scale that is genuinely hard to comprehend. And critically, they have the speed of construction.
That speed seems to be the defining factor here. We hear about data centers in the West taking years just to get approved because of regulatory hurdles and local opposition.
Right. In the West, our system is often defined by what some call a vitocracy. You have fragmented grids, you have lengthy approval processes, you have environmental impact statements that can take years. It is a system designed for caution and consensus, which has its merits, but it's not designed for speed.
And the Eastern model.
The Eastern model, in this context, is defined by state capacity. They treat electricity and compute as public goods, almost like strategic national infrastructure, similar to roads or bridges. If they decide they need a new high-voltage transmission line to power a GPU cluster in the middle of nowhere, it gets built. The decision is made and the resources are mobilized. We're talking months, not years. This ability to align infrastructure with strategic goals is a formidable advantage.
This reminds me of that anecdote about the young venture capitalist you mentioned, the one from the background materials, the one who moved from a financial hub like Shanghai to one of these construction sites.
Yes, that narrative really captures the shift perfectly. He spent his life moving money financialization, derivatives, asset-backed securities, what he called the ghosts of value. Then he stands in one of these massive humming data center facilities, surrounded by concrete, by kilometers of cabling, by thousands of cooling fans, and silicon. And he has this epiphany, he realizes. Moving money is a ghost compared to moving the future.
It's the engineer dividend.
Exactly. It's a governance model run by people who understand supply chains and physics, not just legal frameworks and financial instruments. If you have a problem, say, sanctions on your technology, you don't just sue someone or lobby a politician. You engineer a way around it. You build a workaround. You stockpile. You design a new supply chain. It's a very practical, grounded approach to building national power that prioritizes physical reality over financial abstraction.
But this massive stockpile and this insane infrastructure build-out, it requires immense capital. Who is paying for 429 gigawatts of new power and $10 billion worth of H200s? This can't just be commercial profit footing the bill.
No, it's not. And this brings us to the financial engine behind it all, what you could call the investor state. This is where the economic model diverges really sharply from the West. We're seeing a fundamental shift from asset management to capital management.
That distinction there sounds subtle, but it feels crucial. How does capital management differ from asset management in this context?
In a typical Western context, asset management is about maximizing return on investment, usually in the short to medium term. If I put $1 in, I want $1.20 back next quarter or next year.
Right. Shareholder value.
Exactly. State-owned enterprises, or SOEs, and the big government guidance funds in China aren't operating like a hedge fund or a private equity firm. They are engaging in capital management, which means they are actively investing in technological maturation.
So they are operating on a completely different timeline, with a different definition of return.
A radically different timeline. They're willing to wait. They're willing to take risks that private capital in the West won't touch because the payback period is too long or too uncertain. You might be willing to wait 30 years for a return if that return is sovereignty.
A return measured in national security, not dollars.
If the return is that China no longer needs NVIDIA in 20 years, that is worth more than any quarterly dividend. They have effectively turned domestic substitution into an asset class itself. The entire financial system is being rewired to reward those who build the fortress.
And they're backing this up with very direct subsidies, right? I read about the energy subsidies specifically targeted at helping this transition along.
This is fascinating, and it shows how the financial and industrial policies are interlinked. We know that the current generation of domestic chips, like the Huawei Ascend series, are less energy efficient than NVIDIA's. They run hotter, they use more power to perform the same calculation.
Which, in a free market, that's a death sentence. It's just too expensive to run them at scale.
It would be. A data center operator would always choose the more efficient chip to save on their biggest operational cost, which is electricity.
So the state steps in to bridge that gap.
The state offers up to 50% energy subsidies for data centers that use a certain percentage of domestic chips. They effectively subsidize the cost of that inefficiency.
That completely neutralizes the economic disadvantage of the early stage technology. It makes it a rational choice to use the domestic chip, even if it's technically inferior for now.
It's a war economy mindset applied to peacetime technology development. The state is essentially saying, we know our tech is lagging right now. We know it costs more to run. We will pay that difference so the industry survives and learns. By the time the subsidy is eventually removed, the hope is that the domestic technology has caught up in efficiency. It's a protected incubator, but at a national scale.
It really challenges the core assumption that market forces alone should dictate technological progress. Here, the market is being actively shaped and guided by strategic intent.
Yes.
Yeah.
And it brings us full circle back to the psychological aspect of all this. We talked in the intro about how the West sees sanctions as a door slamming shut. But from the inside, from Beijing, it looks very, very different.
It's the survival instinct kicking in.
The sanctions were the catalyst. That's what you hear over and over. Before the most stringent sanctions, many Chinese companies were happy to just buy the best American chips. It was easier. It was cheaper. It just made good business sense. The sanctions forced a survival instinct. They created a unity of purpose and a sense of urgency that just didn't exist before.
You mentioned a Spenglerian prognosis regarding this dynamic in the source material. Can you unpack that a bit?
Well, the historian Oswald Spengler talked about the life cycles of civilizations, their periods of vitality and decline. In this context, you could look at Western restrictedness, the sanctions, the blockades, as a form of entropy. It's an attempt to stop time, to freeze the current technological hierarchy in place and prevent change.
Trying to lock in the current advantage.
Right. Whereas the Eastern response, the adaptation, the quota system, the stockpiling, the massive infrastructure build, that's vitality. It's absorbing the external pressure and using it to grow stronger and more organized. It's the difference between trying to build a dam to stop the flow of a river and building a hydroelectric plant to harness the river's power for your own purposes.
So the paradox is that by trying to starve the beast, the restrictions actually forced China to organize its entire tech supply chain with a level of discipline and long-term focus that probably wouldn't have existed in a completely free and open market.
We forced them to organize. That's the core of it. We gave them the unifying crisis they needed to mobilize state capacity on this scale. We have to talk about the resilience of that supply chain fortress and the concept of civil-military fusion.
Because the U.S. requires certification that these chips won't go to military entities, that's a key part of the export controls.
But within the strategic framework of civil-military fusion, those distinctions are largely irrelevant on the ground. The fortress is a unified entity. A breakthrough in a university lab working on AI for medical imaging can quickly translate to defense capabilities for target recognition and vice versa. This integration streamlines the entire development and deployment process. The lines are intentionally blurred.
There is also the point about smuggling versus regulation. It's an interesting one. Why does China prefer this legal import channel paying the 25% tariff over just trying to get these ships on the black market?
It's about scale and stability. It's one thing to smuggle a few thousand chips for a specific project, but you cannot smuggle 400,000 units. You cannot build a national AI strategy on the black market. It's too volatile, too unreliable.
You can't plan around it.
Exactly. By using the legal channel, even with a tariff, they legitimize the stockpile. They get the scale they need to build out the national infrastructure. It provides the stability and predictability required for long-term strategic planning. It's the difference between a guerrilla operation and building a standing army.
It effectively legitimizes the accumulation of these strategic assets. It moves the acquisition from the shadows into the national accounts as a formal investment.
Perfectly put. It becomes part of the national balance sheet.
So let's try to bring this all together. We've gone from the loading docks moving 400,000 units of digital steel to the power grids generating 429 gigawatts to fuel them, all the way to the government offices in Beijing issuing the Xinjiang mandates that orchestrate the whole thing.
The big picture here is that the H200, as powerful and as important as it is right now, is just a temporary vessel. It's a tool. The real story is the great convergence of state capacity, of engineering might, and of a very patient long-term vision.
So the H200 is just the fuel for the engine that they are building themselves. Once their own engine is powerful enough, they won't need the imported fuel anymore.
That's the plan. We are witnessing a masterclass in how to turn a blockade into a launch pad. The capacity to absorb these restrictions, reorient the entire national economy, and accelerate infrastructure development on this scale. It suggests a level of strategic depth that goes far beyond simple trade disputes or quarterly competition.
It makes you realize that while one side is playing a game of quarterly earnings and election cycles, the other is operating on a timeline of civilizations. When the history of this decade is written, we might find that the moment the West thought it was turning off the tap was actually the moment it inadvertently flooded the engine of its greatest competitor with the exact fuel it needed to become unstoppable.
It is a profound convergence of intent and capability, and the scale is something we are all still trying to fully comprehend.
Well, we've covered the digital steel, the energy infrastructure that powers it, and the strategic maneuvering that guides it. This has been a fascinating deep dive into the real mechanics of computing sovereignty. We'll be back next time with another look at the systems that are shaping our world.